Our topic is partial derivatives, right? So before starting this topic, few things you need to learn what it is. That, as you can see the title, there are two words: partial and derivatives. Derivatives, everyone knows, you have done many times, right? Of function of one variable, right? This is, we say, independent variable, and this variable is known as dependent variable. In the same way, when you are working in more than one dimensions or for more than one independent variable, suppose you have any functions that equal to function of x and y. So here this z variable is dependent variable and these two x and y are independent variables. Right? That means z is being made or being formed with the help of these two variables. And suppose you have any function of n variables, suppose x1, x2 up to xn. So all these are independent variables and f is depending upon these n variables, right? So this is the basic theory when you are working in higher dimensions. Okay. But why and from where it originates? Suppose you have to calculate area of any plane or whatever it is. So you know its formula is L into P, right? So to form area, to form one thing, you are using two variables, length and breadth. So whenever you are working in more than one, with respect to one more than one variable, there exists concept of higher dimension, right? In single variable, you are working only on real line. Suppose this is xy plane, xy plane, and this is origin. When you are working y equal to fx function, you are working only on real line because you are taking x belongs to R. Suppose domain is R. That means you are working only on this real line. But suppose you are working in 2D when independent variables are 2x and y, then that means you are working on this line also and this line also. Same for n variables. So this is the basic theory that how it comes and why we need it. Next is, before starting partial derivatives, let me introduce you one topic: limit. It's important because you will use it in derivatives also. Limit in one variable, you know how to calculate. Suppose I am giving you that tell me limit of x square. Then you substitute x equal to 0 here and it's 0. But what about if I say you limit xy tending to 0, 0, xy upon x square plus y square? Is that so easy that you substitute which value you will substitute first, x or y? This you need to learn. Or suppose I am giving you any function limit x, y, z tending to 1 to 0 and it is xy square plus z and something like this. Then how you will start doing this, right? That means we are learning here how to calculate limit in more than one dimensions or with respect to more variables. So there is a method to calculate limit. See, as we discussed example here, that you have to calculate limit of x square. That means y equal to x square is the function, and we know a graph of this one is like this. Suppose we don't know graph also, leave that. That means you have to just go x equal to 0 at this point on the line, and suppose this is 1. Then how you do? 1 is here. You have studied this one. Then when you have to calculate limit, you just check left hand limit and right hand limit. If they are equal, that means limit exists. That means suppose you have to calculate limit around this point, then you just go on the left, you just go on the right. ऐसे तो करते थे आप कि लिमिट h टेंडिंग टू 0 f of 1 minus h निकाल लेते थे and 1 plus h निकाल लेते थे. If limit is same, then limit exists, right? But when you are working in 2D, then you just do not go on this line. You have to work on the complete this plane, xy plane. And in this complete plane, except these lines, there can be towards this point, this can be a path, 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 this can be a path. There can be infinite paths towards one point, right? And because when you are working in 2D and suppose this is the point at which you have to calculate limit, you have only a single way to go to this point, either this side, either this side. But when you are working in more than one dimension, suppose in 2D, then this is also one way, 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 this way, this way, this way, this way. There are infinite ways or path you can identify around one point in 2D. Suppose point is here, and there's infinite lines you can draw or path you can identify around this point. And the thing is that you have to check limit with respect to each and every path coming to that point. And if the value is same for all the paths at that point, only in that case we can say that limit exists for that point. Otherwise, if suppose some path exists in all the paths whose value is not same for the function as another paths have, then in that case limit doesn't exist, right? So same concept we are using here in 2D, that first we will check as they have given definition here, that function is said to have limit L as x tend to a and y tend to b if and only if limit L is independent of the path. Independent of the path means for every path value is same for the function, followed by x is tending to a, y is tending to b. Let me give you one example, and you have to check at x equal to 0 and y equal to 0, suppose. Because this is the point around which you have to calculate limit of this function. Then first I will go for this path. Then I will go for this path. I can go for this path. I can go for this path. This. Infinite paths I have around this point. Okay. So according to rule, they have said this. You just go for one thing I forgot to mention here, that when you are working in more than one variables with respect to whatever operation you are operating, limit is also one operation, continuity is also one operation, differentiability is one operation, integration is also one operation, right? So whatever operation you are operating in more than one variables, you have to work only for single variable first. That means suppose you have any functions that equal to fxy, right? And there are two independent variables here, x and y, but it is not possible that you work with respect to all the variables together. As you see here, if I have to calculate limit of this function, then एक time पे सिर्फ एक ही variable I can operate. Rest the variables I have to put constants. It is not possible to work on every variable at a time. We have to, if I am working with respect to one variable, rest I need to put constant. As I cannot put x and y 0 simultaneously in this function. One by one. As I have write it here, I will write it here. I will write it like this also. This value also I will calculate. What is the difference between these? The difference is what I have said right now, that one time one variable. That means first I am using y variable. X I have treated as constant. First I will calculate this value, then whatever function I will obtain, I will work on x. And here first I will work on x and then I will obtain something, some value, and then I will operate y. This is showing you that at one time only one variable we need to take, rest we will take as constant. Okay. And you are independent to choose that which variable you are taking first. It's completely your choice. So, and now you just substitute y as 0. 0, 0. So it will be limit x tending to 0, x by 2x. Then what its value will be? 1 by 2. If you solve this problem here, you just keep x as 0. So it will give you limit y tending to 0, y upon minus y. So it will give you value minus 1. Now you just see 1 by 2 cannot be equal to minus 1. These values are different to each other. That means limit of this function does not exist. In case, suppose this value is 0. For some question, this value is 0, 0 means values are same, limits are same. Then we say limit exists. But that's not too easy in higher dimensions. I said now, whatever you are doing here, it's just you are checking here, here, suppose. What about the infinite ways or infinite path which are coming towards this point? उनसे भी तो वैल्यू सेम आनी चाहिए, उनसे भी तो हमने चेक करना है. But how can you check for each path? Suppose this is y equal to mx, this is y equal to mx square, this is y equal to mx cube. It is itself one path and it is consisting infinite paths inside. Right? So how you will check? So the easy way is that you just go according to working rule. That you calculate x equal to a, y equal to b, y equal to b, x equal to a. If the values in both the step is same, that means limit exists, otherwise not. I have shown you one example. यहाँ से हम दो चीजें सीखे हैं कि अगर हमारी लिमिट ऐसे इक्वल नहीं आती है according to two paths, if you are taking two paths, then obviously limit will not exist. But suppose values are same. From these two paths, values are same. Then we will do one thing, that we will choose one another path y equal to mx, or this is the general path, and now you can take this n from z. So I am taking y equal to mx path, and you substitute in the question here, and whatever जैसे यहाँ पे आ जाएगा अपना function, it will be x plus mx upon 2x minus mx. Why we are doing this? So that our function of two variables or more than two variables can be changed into a single variable. Right? Now I have changed this one in single variable as y is 0, and that means according to this path x is also 0. Solve this one. Now it will be x tending to 0, 1 plus m, 1 minus m. X है ही नहीं, so leave this. Now this is depending upon m. You change the value, you will get different values. If you substitute 0, it will give you 1 by 2. If you put 1, it will be 2. These two values itself are not giving the same value, that means limit doesn't exist. So like this you can, if you are even not doing this process, you just direct substitute y equal to mx in the given question. If it is giving you different values for two values of m, then limit will not exist, and if it is giving same values for all the paths, then you have to check again. Right?